There's a good chance you've worked in organizations with rooms just like you see here. You may have actually been this person, the guy or girl who is the administrator that manages the data center. They may be one of many administrators, but either way, the traditional model we'd have is that there would be racks and racks of servers sitting on-premise and managed by professionals whose job it was to maintain these data centers. They were complex things to run. We're looking at very dedicated hardware here, very specific requirements around things like cooling and fire retardants. And due to the nature of how expensive the equipment in a data center like this is, nothing really changed very quickly too. You needed new servers, that was a procurement process, and that was some number of months to fill out forms, wait for delivery, and then go through installation processes. On-premise data centers were far from agile and were far from cost-effective to run. The cloud starts to move us away from exclusive reliability on data centers like this, and during this module I'll explain what I mean by exclusive as well. And it starts to move us to data centers more like this. This is Google's Iowa data center, and it is ginormous. Now, of course, you would expect a Google data center to be ginormous. They have massive computing requirements. And just for a sense of scale, have a look at how large some of the vehicles are towards the bottom left of the frame, or towards the top center where you can see a parking lot between the two buildings. This thing is ginormous. Now, what it means for an organization the size of Google to build a data center like this is that they can get huge economies of scale. They can start to buy equipment in bulk, spread operational costs across a large number of machines, and automate so many processes of how data centers are run. Whilst this is a really expensive endeavor, by the time you break it down to what it actually costs on a per machine basis, suddenly what Google is doing here actually starts to look really cheap compared to that on-premise data center in the previous screen. Let's take a closer look at one of these data centers. This is what it looks like inside one of Google's data centers. And in some ways, it's not that dissimilar to what you may have been used to on-premise. We've got rows and rows of rack-mounted servers, except there are thousands and thousands of them. And it comes back to this scale proposition again. An organization the size of Google can stand up absolutely ginormous data centers, and they do have many of them too, and create services that can be very cost-effective to run. And because the management of these data centers is now such an automated process, they're enormously agile in their ability to scale up as well. We'll talk more about what we refer to as elasticity as we go through this module. Let's have a look at another picture. This is one of Microsoft's Azure data centers, and what we're looking at here is a very modular implementation, all built out within shipping containers. Now imagine each one of these shipping containers has rows and rows of rack-mounted servers. When they need to expand, they drop another shipping container in. In fact, for that matter, when they want to stand up a data center somewhere, they can take these prefabricated shipping containers and drop them in place. They've got all the right cooling and fire retardants and everything like that built into them, and they're almost a turnkey data center. Except then you have a large number of these shipping crates in order to create data centers with a very large capacity. I'm showing you these pictures to try and move us away from the mentality of a data center being a very rigid, fixed unit within an organization's premise to what we now recognize in cloud as being very large, very highly agile data centers, which you can rent a piece of. And that's really what the cloud is. It's a unit of computing that you can rent on a time basis. We'll talk about those definitions in a moment. Let me just show you one more thing first. This is an experimental prototype Microsoft has been working on, which puts the cloud under the sea. Now, why would they do this? Well, one of the biggest expenses that organizations have in running data centers is temperature control. Cooling a data center is a very expensive exercise. So Microsoft have actually been looking at how might a data center running under the sea be able to better control temperature and keep that really expensive component of operating a data center down as low as possible. But here's the thing for consumers who use any of these cloud services. It doesn't really matter to them. They don't really care whether it's on land or undersea, because when we talk about cloud computing, we're talking about delivering a service for a cost. The physical location doesn't matter, at least not within certain geopolitical constraints, and we're going to talk about those in the next module when we touch on organizational security considerations. But for all intents and purposes, whether it's on the land or next door under the sea, it doesn't particularly matter. Because when you rent servers, you're never seeing them, you're never touching them, you don't go and visit your servers in the cloud. You simply pay for the service. So that's a quick intro to hopefully get you thinking about how we're changing from on-premise to cloud-based computing. Let's now move on and actually start talking about the specifics of cloud. Let's talk about cloud service characteristics.